Aloha, this is problem 74 in chapter 4. We're told that Bob traverses a chasm by stringing a rope between a tree on one side of the chasm and a tree on the opposite side, 25 meters away. As I've drawn here, assume the rope can provide a tension force of up to 29 kilonewtons before breaking. Use a safety factor of 10, that is, the rope should only be required to undergo a tension force of 2.9 kilonewtons. So I wrote some of that information down, and I guess I'll label it DS, the safe maximum tension, 2.9 kilonewtons. And for part A, we're asked if Bob's mass is 72 kilograms, determine the distance x that the rope must sag at a point halfway across if it is to be within the recommended safety range. So safe if T is less than TS, less than or equal to. And we're also given that M is 72 kilograms. And we want to find X, which is this vertical distance of Bob sagging down in the middle. So we can draw a free body diagram for Bob. He's experiencing the force of gravity, mg, tension force from either side of the rope. We can draw a coordinate system here. And we don't know this angle theta here. We know that the tension is going to be balancing each other out in this x direction, but we want to find the component of the tension in the vertical direction from the rope. So just label that theta. So we know using Newton's second law that in the y direction there's no motion, so no acceleration, the net force is 0. This will be equal to 2 times this vertical component of the tension, because we have the tension force actually in those two directions, and minus the gravitational force. So that means and we can see that whatever that angle is, the y component comes from the hypotenuse, which is t times this. They're just using the sine of this angle, so this is t sine of theta is equal to mg. And we're considering the case when, for the maximum distance for x is to be safe is when t equals ts. And we don't know what theta is, but it's related to x by just considering the geometry of this problem. And I'll write now that this is ts, because that's what we're considering. So in the picture we have this big triangle, the x right here, but then we're looking at halfway point. So this distance here is L over 2, and this is really a right triangle here. And we want to relate it to the theta we just used in our free body diagram. So this tension force was coming up this way, this is the theta, and this is a 90-degree angle here, so this is 90 minus theta. That means in this corner, this angle is also theta. So we have this angle, we have its adjacent side and its opposite side, so we can use the tangent to define that angle in terms of some variables that we know or that we want. So that's x over L over 2. So now we have an equation for x. X is L over 2 times the tangent of theta. And we also have an expression for theta in terms of the tension. Sine theta is mg over 2 times this maximum safe tension for what we're considering. That's when we want to find the x value. So theta is the inverse sine of this quantity. We know m, g is the acceleration due to gravity, and we're told ts is also. So then we can just find x by plugging that value of theta into this equation, which we found just from the geometry. So if you plug in the numbers there, we know m, we know L, we know TS, that's 2.9 kilonewtons. You can just write that down. 25 meters over 2. And remember, kilonewton is 10 to the 3 newtons. And if you plug that into a calculator, you should get about 1.5 meters. So that's part A. We just found x such that the maximum safety range would be satisfied. And then for part B, we're asked if the rope sags by only 1/4 the distance found in A. So now we're considering, I'll just call it x with a line over it. X bar is now 1/4 of the x we just found. We want the tension in the rope. So we can use the same equations. We know that x is L over 2. Sorry, that's a 2 tangent of theta. And now we want to find theta, because we can rewrite, we had sine of theta. Basically 2t times sine of theta is mg. Now we want to solve for t, because that's what we're looking for. Mg over 2 sine theta. So we want to put theta in terms of x, because we calculated x, but now we want to use x bar for this case, which is 1/4 of x that we just found in part A. So theta is the inverse tangent of 2. X bar is really 1/4 x for L. So and then we can plug in this equation for theta into the equation for the tension. Where x is the x we just calculated in part A. So again, you just going to plug in the numbers, and you should get an answer that is about 12 kilonewtons.